Now, in this video, we are going to take up one more problem. The problem number 6. Find the maximum torque that can be applied to a shaft of 300 mm diameter. The permissible angle of twist is 1.5 degree in a length of 5 meters, and the shear stress is not to exceed 42 Newton per mm square. The modulus of rigidity is given by 84 GPa. So this is the problem which we need to solve it. So from the torsional equation based on the strength criterion, what we say, T by tau will be equal to Jp by R, or tau by R will be equal to T by Jp. So we want torque, so torque will be equal to tau into Jp by R by cross multiplication. What is Jp by R? Jp by R is nothing but Zp into tau, where Zp is called the section modulus of the shaft and tau is the maximum shear stress. So substituting the values here, since we want the diameter in terms of Zp in terms of diameter, substitute Zp will be equal to pi d cube by 16 because it is a solid shaft into the shear stress. So torque will be equal to pi into the diameter of the shaft is given to be 300, so into 300 cube into tau. Tau is the maximum shear stress is 42, so substitute that divided by 16. On simplification, you will going to get it as 222.66 into 10 to the power of 6 Newton mm. Now we are going to take based on the torsional rigidity criterion. So based on the torsional rigidity criterion, the formula is T by Jp is equal to G into theta by L. So here T divided by Jp is pi d to the power of 4 by 32, that is pi into 300 to the power of 4 by 32, which will be equal to G, which is 84 GPa, which is 84 into 10 to the power of 3 into theta is 1.5 degrees. So convert that into radians, which will be into 1.5 into pi by 180 divided by the length of the shaft, which is given to be of 5 meters length. So 5 into 10 to the power of 3 or 5000. So on simplification, by cross multiplication and simplification, you will going to get the torque value as 349.754 into 10 to the power of 6 Newton mm. So we need to, therefore, based on the strength criterion, we got the torque as 222.66 into 10 to the power of 6 Newton mm. And based on the rigidity criterion, the torque is 349.754 into 10 to the power of 6 Newton mm. By comparing these two, we can know that the torque based on the strength criterion has got the lesser value. So we need to have the lesser value of torque. Therefore, the torque of 222.66 into 10 to the power of 6 Newton mm has to be applied. So the maximum permissible torque is smaller among the two values. Therefore, the permissible torque T will be equal to 222.66 into 10 to the power of 6 Newton mm. So that means it will be 222.66 kilonewton meter. So this is how you will be able to solve this particular problem. Thank you.